Okay, so this lesson is about circuits, but we should introduce some symbols first. So the battery, it has a potential difference V and supplies current I to the circuit, so it will have a potential difference. We call this, the longer dash is the higher potential, which is the plus. The lower dash, we call it as the negative potential, which is the minus. So current flows from the higher potential, it goes from plus and back to the lower potential, so minus. So this is the direction of the current flow, flows this way and returns this way. Then we have resistance, which limits the flow of the current. And another thing that we should keep in mind, that we should know the polarity of the resistance, which part is positive and which part is negative. So at this part, it's the first time the current encounters the resistor, so we put it as positive, and it exits from this part, so we put it as negative. And we have the switch, which turns on the circuit and off. So let's do a quick example. So let's say that I gave you the following. I told you I have the following circuit. So let's say here we have the switch and it is a closed switch. So when the switch is closed, we have current that is flowing from the positive side of the battery into the resistor and back again to the negative side. The polarity of the resistor, so this is the first encounter between the resistor and the current, so put it as plus and this would be minus. So this is voltage of the resistor, this is voltage of the battery. If we have an open switch, we have something which we call as an open circuit, which means no current will flow. So this is an example of an open switch, or we call it also an open circuit because no current will flow since the circuit is open. Okay. Then we have something which we call the series and the parallel circuits. So let's start with the series circuit. This is a simple series circuit, which means that we have a battery with resistors. So we can have series connection, but without battery, which we will talk into the next lesson. So let's say that we have a 5 volts battery, and let's say that we have two resistors. This is 100 ohms, and let's say that this is 200 ohms. Let's call this as R1. Let's call this as R2. So in series, they called it as series circuit because of the following. Because the resistors are connected in order, so the first resistor ends, the second resistor starts. And also that the current flows in one path, so the current will exit the battery from the positive side. It will flow through the first resistor and it will flow through the second resistor and back to the battery. So as you notice that the same current is flowing through both resistors. So let's call this current as I total. So I total, which is the total current, is flowing through both resistors. And we have some properties, which is we can find R equivalent, or the total resistance, or the resistance that is viewed by the battery. So it has many names. So R equivalent or R total is simply adding the two resistors. So it is R1 plus R2, which is in this case is equal to 100 plus 200, which is 300 ohms. Now after finding the total resistance, we can find the total current, and total current will always be equal to the following. It will always be equal to the voltage of the battery divided by the equivalent resistance, which is equal to 5 volts divided by the equivalent resistance, which is 300 ohms, which will be equal to the following. So 5 divided by 300, which is 0.0166 amperes. Since the same current I total is passing through resistor 1 and 2, so we say that the current on 1 is equal to the current on 2 and is equal to the total current, which is equal to 0.0166 amperes. So this is another rule, that they have the same current. Because the same current is passing through them, it means that the current over here is equal to the current over here. However, now let's talk about voltages. So here the polarity of the first resistor, it's plus this way, minus here, so let's call this V1. Here it's plus and here it is minus, so it is V2. Now, do they have same voltages? Yes or no? They won't be having the same voltages due to the following. So we say voltage 1 is not equal to voltage 2, because voltage 1 is equal to resistance 1 times the current, while voltage 2 is equal to resistance 2 times the current. Even though they have the same currents, however, their resistances are different. So let's calculate V1, let's calculate V2. So voltage 1 is equal to resistance 1, which is 100, multiplied by current, which is 0.0166, which will be equal to 1.66 volts. Voltage 2 is equal to 200, which is R2, multiplied by the current, which is 0.0166, which is equal to the remaining, which is 3.33 volts. And if you add V1 to V2, you get the total voltage of the battery. So let's add another rule, which says the following: and the voltage of the battery should be equal to voltage of the first resistor plus voltage of the second resistor. This is coming from the law of conservation of voltage. Remember that voltage was equal to energy per charge, so it's also related to conservation of energy in a way. So in one of the questions, I might give you the following: I might give you voltage on one of the resistors, I might give you the battery voltage, and I'll tell you this is an unknown resistor, find the value of that resistor. So you just subtract voltages, you take that remaining voltage and you divide it by the current and you get the unknown resistor. So this is a series circuit. Let's do a parallel circuit. So in parallel circuits, the current would have more than one path. So let's draw a simple parallel circuit. Same circuit, this is R1, this is R2. Let's say that R1 is the same one, the whole 100 ohms. R2 is the 200 ohms resistor. And this voltage, let's also make it same as well. Now here we have the following. So let's say that the total current is exiting. So when it reaches this junction, it's the collection of more than one wire. So it would have now two options, or two paths. So it will divide and flow over here. Let's call this as current 1, and the remaining will flow through the second resistor. So let's call this as current 2. And then they would reunite again at this junction back into the total current. Okay, so in parallel, to find R equivalent, we do the following. It is equal to 1 over R1 plus 1 over R2 plus 1 over R3 and so on, which is equal to 1 over 100 plus 1 over 200, which would be equal to 66.66 ohms. Then again you can find the total current using the following. You say total current is equal to voltage over R equivalent, which would be 5 over 66.66, which is equal to 0.075 amperes. Now regarding the voltages, V1 and V2, they would be equal due to the following reason. Both resistors start together at one node and they end together at another node. So it say that V1 equals to V2, which is also equal to voltage of the battery, which is 5 volts in this case. So this is in parallel. In the simple parallel, if they're directly connected to the battery, they have the same voltage of the battery. They don't have same currents, so current 1 is not equal to current 2 due to the following reason. This is voltage 1 over resistance 1, This is voltage 2 over resistance 2. They have the same voltage, yes, but not the same resistances. I'll continue in the next portion of the video. Okay, so here let's calculate current 1, which is voltage over resistance 1. What is the voltage? 5. What is the resistance? First one, which is 100 ohms. So current 1 would be equal to 0.05 amperes. Here it would be 5 over 200, which is equal to 0.025 amperes. Now what do you notice? If you add current 1 to current 2, you will get the total current. So I total can be found in another way, which is adding of I1 plus I2, which is equal to also 0.075. So this was 0.075. And let's solve some examples regarding this from the worksheet. So here we're saying a 12-volt battery is connected to 3 resistors and they are in series. What is the equivalent resistance? So we said that equivalent resistance in series is equal to R1 plus R2 plus R3, which is equal to 6.75 plus 15.3 plus 21.6, which is 43.6 ohms. What is the current in the circuit? We know that the current is equal to the following. So current total is always equal to voltage over R equivalent. This is the total current, which is equal to 12 volts divided by 43.6, which is equal to 0.275 amperes. Second one, we're not given here the voltage of the battery. How can you find voltage of the battery? You find voltage on each one, then you add them all up, you get the voltage of the battery. It was not asked in the question, but this is how you do it. And we said that they have the same current, we have each resistor, so we can calculate V1, V2, V3, and if we add V1 to V2 to V3, we get voltage of the battery. We get something a little bit harder. Okay, connected parallel, what's the equivalent resistance? Okay, this is easy. Okay, this is 9. Question 11. So in question 11, we don't know what's the voltage of the source. And we have the following givens. We have here 9 ohms resistor, we have here 6 ohms resistor, and they are both connected in parallel to the unknown voltage. And we also have an 18 ohms resistor also connected in parallel. So they told us the following, that we have a current of 4 amperes passing through the 9 ohms resistor. So let's call this one as R1, this is R2, this is R3. So this is V1, this is V2, and this is V3. Again, why did I put the plus and minus like this? Because the first encounter of current is this way, so it would be plus. Anyway, so we're saying calculate equivalent resistance of the circuit. So we say that R equivalent is equal to the following, is equal to 1 over 1 over 9 plus 1 over 6 plus 1 over 18, which is equal to 2.99 ohms. B, they are saying what's the potential difference across the source. So they want the voltage of the battery. So we know that V1 should be equal to V2, should be equal to V3, and it's equal to voltage of the battery. Regarding V2, we can get it because we have, regarding V1, we can get it because we have current 1 flowing in resistor 1. So we have the 4 amperes flowing through the 9 ohms. So here we say 4 times 9 is equal to V2 equals to V3 equals to V. Why did I use this? Because we know that V1 is equal to R1 times I1. We have R1 given, yes, we have I1 given. So 36 volts is equal to V2 and is equal to V3, which is equal to voltage of the battery as well, since they are all in parallel. So part C, we are saying calculate the current in the other resistors. So now we have voltages of all of them, so we can simply say that current is 2 is equal to V2 over R2, which is equal to the 36 volts divided by R2, which is the 6 ohms, and will give us 6 amperes. I3, which is equal to V3 over R3, which is equal to 36 volts divided by 18, which is equal to 2 amperes. So I'll do those two questions also. So here it's saying the following: several light bulbs are connected in series across a potential of a source that has a potential of 115 volts. What's the equivalent resistance if the current in the circuit is 1.7 amperes? And what if each one has a resistance of 1.5 ohms? How many light bulbs are in the circuit? So we have 115 volts. Over here we have an unknown resistors that they have the same value. So R equivalent, we know that is equal to R1 plus R2 plus until Rn. Since they all have equal values, as if we are multiplying them by their number, so we say that R equivalent is equal to N times one of them, R1, let's say. So first we need to get R equivalent. So how do we get R equivalent? We have voltage of the battery given, and we have the total current, since we are connected in series, which is 1.7 amperes. So we say that R equivalent is equal to voltage divided by current, which is equal to 115 divided by 1.7, which is equal to 67.6 ohms. Then we say that 67.6 is equal to N multiplied by 1.5, which means that N is equal to 67.6 divided by 1.5, which is 45.09. So 0.09, we don't have 0.09 bulbs, we say 45 bulbs or lamps or whatever it is. Question 15. So in question 15 it's saying the following: find the missing values in the following circuit. We have voltage of the battery, we have the total current. So we say that R equivalent is equal to voltage over current, which is 9 divided by 0.045, which is equal to 9 divided by 0.045 equals to 200 ohms. Then we say that the 200 ohms is equal to the two resistors that are in series, the 2R plus the 3R, which means that 200 is equal to 5R, which means that R is equal to 200 over 5, which is equal to 40 ohms. Then we can calculate each one. So first one, with 2R is equal to 2 times 40, which is equal to 80 ohms. And the other one, the 3R, is equal to 3 times 40, which is equal to 120 ohms. Okay, so a length of wire is cut into 5 equal pieces. The pieces are then connected in parallel, with the resulting resistance being 2 ohms. What was the resistance of the original length of the wire before it was cut up? Now we have a specific thing that you need to know. If we have two resistors of equal values, so R1, R2, so let's say that R1 equals to R2, which means that their equivalent in parallel will be equal to R1 divided by 2. So one of them divided by the number. So let's say I had 3, I divide by 3. I had 5, I divide by 5, and so on. So here they are saying we have 5 resistors connected in parallel with resultant resistance being 2 ohms. What was the resistance of the original length before it was cut up? So we'd say that R equivalent is equal to one of them divided by 5. So we say that 2 is equal to R1 divided by 5. Then we'd say that R1 is equal to 2 times 5, which is 10 ohms. Okay, and then we need to add up all resistors back to the full resistor. Since they told you that the length is cut up, it means that length is directly proportional to resistance when we add them. So we just add R1 to itself 5 times, which is basically multiplying. So 10 times 5, which is equal to 50 ohms.